And now I'm going to talk about how JRebel for Android does performance testing and performance regression testing in particular. So if you don't know JRebel for Android, we are a build tool, an IDE plugin really, that you can install into Android Studio, and it will sort of supercharge your development and make things faster. So for us, performance is paramount. It's the core feature of the product. And that's why we really need to do performance testing and performance regression testing in particular, so that we, like the new version we ship out, that it wouldn't end up being slower than the one before that. Having said that, our experience is with relatively long-running tasks like Gradle builds. So from an app developer's perspective, some of this might be useful, some of this you might need to transform a bit to apply to your apps, but it can sometimes still be useful. So I'm talking about things that run for half a second or longer. So if you want to know which kind of a for loop is faster, how to hit that 60 FPS, how to fine-tune your garbage collector, I can't really help you there, but I can talk about long-running processes. Like app startups, a code app startup is really important to your app. It's the first experience somebody has when they start their app after installing it from the App Store. Or another good example of a long-running task that you might want to measure is level loading times. If you're working on a game, then the time that it takes to load a level is really important to your users. So before we get to the nitty-gritty, let's talk about some philosophy even. If we talk about performance, there is a question that we want to know, or there is an answer we want to know, and the question could be, is my app fast? Is the app fast? And that's a really soft question. It's borderline philosophy. What does fast mean, and how to get there? So I'm an engineer. I don't really like soft things. I like hard, quantizable, measurable things. So instead, I would ask, is the app fast enough? That's already a bit better, because now I can set an anchor for myself. I can say an app that starts in 2 seconds is better or is already fast enough, or an app that starts in 1 second, whatever. So it's already a bit better, but it's still really not measurable. How would you define what the enough is? It's still something you would probably like pull out of thin air. So a better question would be, is this version of the app faster than that version of the app? And now we're in this awesome land where everything is the same, only the version is different, and I can quantize the question. I can take data, I can measure my app, like I can measure this version of my app, I can measure that version of my app, I can compare the results, apply some data science, magic, whatever, and I can come with a concrete answer. Yes, it is, or no, it isn't. And since all engineers are pessimistic by heart, I actually want to ask, is this version slower? It's essentially the same question, but I'm looking for failures, not successes. So the question is this version slower than that version? Or did we ship a version that is slower to the previous one? The easiest way to answer that, and the way most people or most teams approach this, is they add analytics. So they start taking measurements inside their application. I hope you're doing that to some degree. They post it to the internet, they collect the data, they aggregate it, and then they view the results. And that's already awesome. Too loud? Yeah. Is it better? OK. And that's already awesome. If you're asking that question, you're already collecting data, and you can find out if the new version was worse or not. There is a problem here, though. If you do a bad commit, it will take a while until it gets out there. It will take a while until you get enough data that you can tell this version is worse. Then it will take a while to actually find the offending commit that you put in, fix it, push out the new version, wait for data again so that you can verify or fix, and then finally you can say, yes, we fixed the problem. And if you ship maybe once a month, then that can be already a quarter or more. And that's a quarter where your users are using a subpar version of your app. So that's not good enough. Another problem with collecting data, even though it's awesome, is you have no control over the environment. So you would ship a version, You would wait a month, and then you would see, like, OK, it's a bit slower, but what happened? And it could be that instead of your app being worse, you launched in a new market that has a lot of like lower-end, slower Android devices. And they would also like bring your statistics down. So you have no control over the environment. You don't actually know what it is. You don't know what networks your users are using. So you will see some data, but it's hard to, again, quantize and understand what's actually happening there. So a better way to approach this is benchmarking. You elect a guy from your team, some poor guy, and the only thing he does for a full day is he opens the app, starts doing some operation, has a stopwatch on the side, and that takes measurements. And it takes like tons of samples and gets some times out of them, puts them in a really big spreadsheet somewhere, and does this over and over again, weeks and weeks. And this is what we did about a year ago. And it took, I think, a few months, and then this poor guy filed a JIRA ticket saying, like, OK, we need to find a better way for this, because that's like a really bad way to allocate your resources, or like you're spending somebody's full days just to get this data. And you could automate this. Another problem with doing it manually is you're probably doing it once per week, once per month, once per version, something like this, and you have hundreds of commits. So you know that the new version that we're about to release is slower due to benchmarking, and the previous version was better, but there's like 200 commits separating the two. So now you attach the profiler, you take method traces from this end, you take the old version, you attach the profiler, you take the method traces from that end, then you compare them, you try to find what went wrong, and finally you find this like total innocent commit that says, like, I added feature foo, just enable it if you want to try it out, and that's it. And if you're really lucky, if you're in an ideal world, then the commit would look something like this. I added feature foo, and oh, I also made the app startup a bit slower. But this never happens. I mean, nobody writes a commit like this, because nobody actually knows that they pushed something that's broken. And there is a nice analogy here. If you push something that breaks the app, that introduces a bug, we know how to fix that problem. We know that if you add tests, if you add regression tests, you can make sure that this bug never happens again, that if a developer breaks it, they can go back, run the tests, and they get this instant fast feedback. So how do we get the same thing for performance? Well, we need to automate a lot. So we sat down, thought, like, OK, we're going to do performance regression testing. We want to find out when these things happen. And we need a harness of some sort to run the tests. I'm not going to go too much into detail here, because we're a build tool, so our harness has actually nothing to do with Android apps, not directly at least. But we developed something that is sort of like a high-level way to script user actions while they were using the tool, so sort of a DSL. I think like the closest thing on Android would be probably espresso tests or something like this. So we had this high-level way. We could script the user actions, and then we thought, like, we could repurpose the same thing to still do those actions, but also measure the time it took to complete them. So now we have an automated way of doing what the poor guy did with his stopwatch. We could run some user actions, we could measure them. We also wanted to pinpoint specific commits, or at least a few commits at the same time. So in our case, that meant that we would take a machine, a dedicated machine. We would run these tests in a loop every day there. So that was once per hour, because they took a while as well. And we would do this 24/7. So this machine would be just marching away in the server room somewhere, just testing JRebel for Android over and over again. So if something went worse, we would have 1 hour of commits. And that's something that you can already look at. And we also needed to make regressions noticeable. What I mean by that is getting consistent results. There's a really good example here with artificial data. So imagine that we have an operation that takes 8 seconds. And we have an error rate of ±2 seconds on that operation. So it's totally artificial, but say these are my 20 tests. And in the middle, after 10 tests, we actually have a regression where the operation is 800 milliseconds slower. And if you have such a high error rate, it can actually hide it can hide the regression. You can look at it, but you won't see it. If you run a lot of tests, you take averages, you will start seeing it, but you won't see it at the first glance. So if I do the same regression with a much lower error rate, with plus minus 200 milliseconds, then it's sort of there. I'm not sure if you can see it. Like if you squint really hard, you can see that the first half maybe is a bit lower, and the second half maybe is a bit higher. But it's already a lot better looking at something like this than looking at something like this. So you really, if you start taking any kinds of these measurements, you really want to bring the error band down so that it's narrow. And for us, that meant a lot of things. First off, as I already said, it meant a dedicated machine. So you must lock down the environment as much as possible. You must have the same OS, the same disk, preferably the same computer. You cannot do any network, because that will immediately introduce a lot of variables to your system. Yes, that's pretty much it. You cannot do any network. So we started out doing this with hardware. We took a Nexus 5 device. And as you can see, especially with the help of my ultimate image editing skills, 6 runs in, and we saw a huge bump of 2 seconds, and then it stayed there. And we were looking at this, trying to figure out what's the problem here. Every time we would run the test, we would get 6 nice results, and then it would bump, or maybe sometimes even 4 results or 5 results. It would bump, and it would stay on this higher level. So if you know ARM processors, they have a thing called thermal throttling. So all phones actually get hot. They're not designed to run at the frequencies you see like on the spec sheets. If you run them like at full throttle for a while, they will get hot. And what will happen is the CPU, like this dog here, will think, yeah, this is fine. Just throttle down a bit, go to a lower frequency, and your phone becomes slower. And the longer you keep the pressure on the device, the more this starts happening. So it will get like really, really slow eventually. So we had to throw that idea out of the window. Like, we cannot test on actual hardware. OK, let's try the emulator instead. So this is a lot better. Previously, for this device, you could see like a 2-second spread. With the emulators, we would have around 200 millisecond spread, so that's already pretty awesome. It's nice, it stays on roughly the same level. There is a small problem, though. Like, if you look at the first 3 events, then you can see like a small slope. So that's the emulator warm-up. We didn't really do any like scientific investigation. Nobody went into the emulator sources. Nobody really figured it out, but it's probably like all of the JITs, the emulator itself, everything warming up, also the file system caches warming up, and so forward. So if you count the samples, we have 13 samples here. And 13 is a magic number for us, because we throw away the first 3. Probably, if you do any kind of performance testing, you might want to do the same thing. Just throw away the first few samples until things warm up, and you get like a more consistent result. Because the goal here, it's not to measure what the users have, because the users will have sometimes like your not warmed up results. The goal is to find regressions in performance when things start going worse. So we would have 10 samples. We have around 20 performance tests, maybe 30 now. And we run them once per hour, 24/7 in a loop. So that's about 5,000 data points per day. You need some way to analyze them. You could, again, elect a poor guy who goes into Jenkins, opens the build logs, grabs them, finds like all of the measurement results, again puts them in the same spreadsheet, and then calls it a day, and you can draw graphs, and everybody's happy. Well, with 5,000, that doesn't really work anymore. You probably need to hire like multiple guys just to do that. So it doesn't really scale, and if you had more tests, you needed to hire more guys. So we wanted to find a way to analyze them as well. And instead of Jenkins, we picked Kibana, which is a dashboarding, graphing tool kind of thingy. It's what the backend people use. And it's called collectively as ELK, which stands for Elasticsearch, Logstash, and Kibana. So Elasticsearch is a document storage server. You can just put like JSON into it. It will store it. It will give you querying, aggregation, a lot of nice stuff. You have Logstash, which is used for processing incoming data and storing it in Elasticsearch. And then finally, you have Kibana, where you can build queries. And then you can take a look at them, do analysis, do aggregation, do all of those cool things. So if you are from the backend world, then you might have seen this being used for like monitoring server health status, like how much RAM is available, what's the CPU usage, stuff like that. And for our case, for measuring performance, it also worked quite well. Because it's real-time. It doesn't have any kind of structure or schema. You can just put random JSON documents in there, and then you can immediately start graphing stuff. For instance, this pretty much is our Logstash configuration. We have an HTTP server listening on some port. It's taking some JSON stuff in, and then it's like putting it into Elasticsearch directly. So you could just use curl, make queries there, and then look at the data later. Of course, using curl is a bit cumbersome. So if you're from the Android world, you would probably create a simple POJO or a Java object. We need to know the version, we need to know the test name, and we need to know the measurement, time millis, for instance. And then you can just use retrofit to populate Elasticsearch with data. I hope most of you know about retrofit. If you don't, then definitely check it out. It's an awesome way to interface with REST stuff. And I'm going to go show a quick live demo as well of Kibana, because what could go wrong? So I have nothing. I have an emulator as well. Let's hide that for now. So I have a really, really simple unit test that sleeps for 1 second, captures the nanotime before and after that, captures the difference between those two measurement points, and then reports it somewhere with the test name thread sleep. I use nanotime because if you use system current time millis, then that's actually not a stable time source. You could be really unlucky, and while this thread is sleeping, the machine could get like an NTP time update, and then you could get a negative result, for instance. Like this thread slept for -200 millis. So on the JVM, use system nanotime. On Android, there is something called system clock, and it has elapsed real time, which could be used for taking measurements as well. Never use system current time millis for these purposes. And the report measurement just prints it out, creates the same Java object I showed you previously, and then goes directly into retrofit. And that's pretty much it. So if I run this, yeah, it's sending out data. And if I open Safari, then we can already see that I'm getting data in. And this is Kibana, getting data into my Elasticsearch cluster. So let's take a look at one of the events here. Oh, that's too big. Is this readable? Yes, awesome. So it's totally unstructured. I get the timestamp. I get the version of the message for free. I get all of the HTTP headers I sent, so you can put stuff here. I get host, the test name that I put in the POJO, the time millis, and the version of my app, which is very boring and 1.0.0. And if I wanted to, I could immediately start visualizing this. So let's create a vertical bar chart from a new search. You can filter the results with a search if you want to, but in this case, this is all I have in my Elasticsearch cluster, so I'm just going to go with wildcard. And it sent 25 events, which means the test has completed. We can bucket it through date histogram. Let's see how that works. Not very well. Give me seconds. Let's zoom in a bit. So yeah, here are all of my test results. And right now, I'm aggregating them by count. So I probably want something like, say, median. Awesome. So that's, I mean, very nice and straight, because sleeping 1,000 milliseconds usually takes around 1,000 milliseconds. or a few more as it appears. Cool. And let's just change the value and run the whole thing again. Change the time as well. So Kibana is completely UI-based. What you saw initially was like a fully non-configured default configuration Kibana. It just connects to localhost and starts getting data. And you can build your queries inside here. You can save them, export them as JSON, and you can already explore your data right here. Let's refresh. So yeah, now I got my second band of results, which is around 1.2 seconds. Cool. Let's do something a bit more practical as well. So I have a really small project. It's also on GitHub. I will have the link later. And I want to measure startup times. And this is a bit more complex, because normally how you would measure startup times is you would probably put something in the beginning of application on crate, and then maybe put another end event in your first launcher activities on resume, which is when it's visible to the user. But in my case, I want to see the full end-to-end time, including VM boot up. So it becomes a bit more complex to also see how long does the Android's own initialization take. Like if you click on an icon, there is a while the VM starts to boot up until you actually hit your application on crate method. And I want to include that as well. So it's a bit more complex. So I have two activities in my project. I have the main activity. That's the one that we want to measure. And we have the measure activity. And I put this one into a different process. So what that means for Android apps means that this activity, if I launched it directly, it will spawn a new VM, but it will spawn a VM only for the measure process. And if I, from within that activity, launch my actual main activity, then that will again spawn a new VM for the app's main standard process. So now I can actually run some code before the VM even boots, so I can take a more accurate measurement. And let's go to measure activity as well. So all this does is it starts up. It takes, oh, there's a bug here. Can anybody see the bug? It takes the start point from system clock elapsed real time. It logs something, and then it starts my main activity and finishes itself. The bug is, it would be a bit more correct to do that. Otherwise, you were measuring the logging time together with the starting time. Not a big deal, though. And when we're starting main activity, I'm just putting in the starting point as an intent extra. So I'm passing this into my main activity. In the main activity, we have this extra. It's doing something totally boring. And in onResume, I capture the endpoint. I check that if we're in this sort of measurement mode, if somebody sent in a start point, I take the difference between the two times, and then I used an async task because I'm old-fashioned. I send the time MS into the async task, and then from there, I send it directly to the host computer and into Kibana. This magic IP only works on emulator, though. So if you're running on an actual device, you probably need to find some way to interface with a Logstash server you have set up. And yeah, from here on, it goes exactly to the same code as with the unit test. It goes out into report measurement, that goes into retrofit, goes into Logstash. Logstash puts the result into Elasticsearch, and everything is good to go. Cool. And I did a small Gradle task for this as well. That just does for stop, and then in a loop, 40 times starts this measure activity. I'm not going to go too much into detail here, but it's on GitHub if you want to steal it or improve on it or do something like this. Yeah, measure and debug startup. Fingers crossed. Never know with Gradle. And if we look at the emulator, we can see this just happening over and over again. The app itself is a really, really basic hello world that just tells the user the current time. Cool. While this is going on, let's already we can go back to Kibana, and we see we're like getting new events in. And I can zoom in here, and then I will see the raw data and the output for those. So since this is a really, really simple Hello World app, you can see it's actually quite fast. It boots up in 65 milliseconds, or 83, it's varying a bit. And since I have multiple, let's make this wider again, last 30 minutes. Since I have multiple things, like multiple tests, I can start making some queries as well. So I would say test raw equals startup. And this would filter out the previous thread sleep tests I did. So now I only see the startup times. Cool. Has it finished? Oh, no, sorry, wrong window. Yeah, it has. Get rid of this. So right now, to display the date in main activity, I'm using Java util date. And a lot of developers will tell you, especially if they're from backend, like never use Java util date, use Joda time. It's a lot better. So let's do that. I have a special branch called Joda time, and it replaces it with Joda time, datetime now to string. And let's repeat the same test. Look. Yeah, it's going at it, awesome. So now I have some measurements coming in as well. We can already see it's a bit slower. That's cool. I also added a Joda time suffix to the version. This will become useful later. And let's see. I can actually start building. So let's say I want to compare the startup time of these two versions. I just did a commit. You can already see I probably introduced a regression, but let's actually visualize it. So let's do a vertical bar chart again, because it's the most boring one. So it's startup. I have 76 of them. Might be right. I want to see, say, the median of time millis. And this time, I'm not actually bucketing by the date. I'm going to bucket by some terms. And terms means any value within your JSON document that you sent in. So I can use version here. And version raw is actually better. So let's run this. Awesome. And here I can see the median for 100 Joda time is around 182 millis, and the median for my really simple Java util date version was 100. So we have detected a regression. And what we would do as developers, immediately the first thing you could do, you could just revert the commit. We're better, or we're back at where we were before. Or alternatively, you could fix it. So there's actually a problem with the standard Joda time, that it's using class buff resources, which is slow on Android. And there is a fork of Joda time called Joda time Android, that supposedly fixes this issue. So let's run again. And I should already be getting in some data. No. Let's try again. Yeah. So this, I haven't finished all the tests, so the value might change a bit. But you can see, like, we started with 74 millis. We had a huge regression in 182. And we're still slightly slower with Joda time Android, because it still needs to do some initialization. But it's a lot better. The regression isn't as bad as it was before. And maybe I really need this library, so I can live with it. So that's Kibana in a nutshell. And I think it's awesome. I tried to use it in a lot of different tools. It's on GitHub. There is no README whatsoever, because I finished this yesterday in my hotel room. I will write the README today, I promise. And we have some time, so I want to show some cool use cases, some actual graphs that we have from our own product. How many of you use feature flags, or feature toggles, or feature switches? OK, some, but not all. So for JRebel for Android, we ship once per week. So that means a lot of the time we're actually developing stuff that we're shipping, but it's not ready for prime time yet. We don't want the users to see it. So we have these toggles in our product that disable this, and then when we want to test them or when we're developing them, we enable them locally, and we might even enable them for like a small percentage of users so that they could test it for us a bit, and we would get better feedback. And in addition to these feature-specific toggles, we have one huge toggle called experimental that turns on all of them. So when we started doing performance testing, our first thought immediately was, let's run it twice. So let's run it for both our experimental flag and our experimental flag disabled. So we would get performance results for stuff that we haven't put into production or not going to put into production yet, and we could compare it against the non-experimental version. So this is oh, it's really bad on this projector, actually. Can you see the two graphs overlapping? It's, I guess that doesn't help. So you have to imagine there is a graph that goes like this, and then there is an overlapping graph that goes like this. I think this is a 1 month period in June where we start doing our experimental incremental Java compiler, and we were validating this through this performance test. And the graph joins in the end, because then we decided to ship it. It's not experimental anymore, so the actual baseline would go down as well and join the experimental line. We also use this to detect regressions early. So this is a graph showing 1 week, where for 2 days we had a performance regression. Only with the experimental flag, we could quickly detect this, fix the problem, and then go back to normal. If we didn't have this, we might have not even noticed, we might have shipped it and actually made the product worse, not better, as we set out to do. And sometimes you can also verify fixes. So we had a problem where reflection was around 100x slower than it was normally. So a lot of customers came to us saying that whenever I use JSON together with JRebel for Android, it's really slow. Can you do something about that? And then one user actually took a profile, took the method traces, sent it to us, and told us, that's the method you need to optimize. That's the one that's slow. So we obviously had to do it. But at the same time, we added a performance test so that we could see that we had fixed it, and so that we could never break this again. We're almost as close as the normal runtime now, and we intend to stay there. And sometimes you see some really, really funny stuff as well. So one morning I came to work, I looked at all of our performance tests, and it was better across the board, and nobody knew why. It's like, who pushed something awesome? Like, who did this? And nobody knew who did it. So it turns out we just switched tools. So we went from the old Emulator 1 provided by Google to the Emulator 2 to run the tests, and then the performance was better across the board, which is still awesome because it was more consistent, and yeah, why not? But that's why you need to lock down your environment. Like, anything you change will have a change here. It also means over a longer time you cannot compare results. So just like two adjacent versions, for instance, are comparable. And another cool thing, we've been doing this for 6 months. So since Kibana stores everything, we can just take a look at the whole 6 months in general and see what has happened. It's not really useful from an engineering standpoint, but it's just tells a cool story, and everybody really likes a story. For instance, you can see when we had the outages. Like, we had 3 weekends when the Jenkins cluster was down, so we didn't have any data for those weekends. You don't really see there, but it's 2 overlapping graphs as well, like ongoing developments. There's a huge spike there as well, which is a regression probably. We had a bug in our own test harness that took wrong measurements. We fixed that, not a real performance improvement. This is the one where we switched emulators. And another development there. I think this is beginning of October when we shipped a new incremental compiler with 2.0. That also made things a bit faster. And to be fully honest, I captured this on Thursday. We had an ongoing regression. I think it's solved now. We're really happy with what we have right now, but we're missing a few key parts. We have no alerting, so when things go bad, somebody needs to be looking at the graph. Ouch. Yeah, when things do go bad, they go. Somebody needs to be looking. Ideally, we would have alerting, so everybody would notice, like a cup breaking or something. So we just eyeball it. We have this huge fat graph that's giving us like 1 week test data. I try to look at it every morning. We also definitely take a look at it before we ship something out, just to be sure that we haven't made anything worse. And cool, that's actually all from me. The slides will be available on SpeakerDeck. My Twitter handle and GitHub handle and all of the handles is Madis. And I have definitely some time for questions.
Okay, are you able to hear me?
Yeah.
Do you have any experience of using Grafana instead of Kibana?
No. Our DevOps team actually uses Grafana, and I don't know why. What's the difference?
Well, I'm actually in backend team, and we are also gathering some statistics, not only from performance side, but it will be nice to join all together and also see performance on Grafana. So if it's possible, that would be great.
Yeah, I think it probably is. I mean, I've only seen Grafana, so I've only seen the graphs, but I think they're maybe related. They look very similar tool-wise. And of course, like, this is only how we do it. It's not like the way to do it. So you don't even have to use Kibana. Probably, like, if you use an analytics tool for your end users, you can probably repurpose it for your tests as well, like Mixpanel or Google Analytics or whatever. Like, whatever can aggregate data and just display it on a dashboard will work.
Just parse JSON and do whatever we want. Yes.
Yeah.
Thank you.
Are there any more questions? So I am a total Kibana noob. How much time does it take to set up and maintain whatever Kibana itself?
Maintain, I'm not giving any promises. Setting up, I can show the config files actually.
Or is there maybe some, I don't know, like cloud-based Kibana where you can just drop your data to?
Probably, I don't know. Kibana, I think I'm running it pretty much default. The only thing I changed is like you need to give it an Elasticsearch URL to talk to. Everything else that you just saw was default. I didn't configure anything. I didn't do anything that. Elasticsearch I was running fully default on my local machine, but on the actual backend, since we have 6 months of data already, I had to bump the heap a bit. Otherwise, it would like start choking. And Logstash is, yes, like there is an apply. Oh, sorry. Like showing stuff and not actually showing it. Like Logstash, it's pretty much what I had in the slides. There is this template here. That's actually a funny thing. So I don't exactly know what it does. It's some magic I copy-pasted from the internet. But for all string fields, since Elasticsearch is done for document searching, so if you have something like dots in your parameter names or values, for that matter, it will actually try to parse them as natural language. So this template adds the .raw format of all the fields so that I could search them as full strings, not as natural language. But I think like the example configuration had it by default for Logstash. And these files are all also in the same repository under config folder. But it doesn't take long to set it up. I think most of the time you will spend actually like the first time just clicking around and getting acquainted with the system, like how to build queries, how to build visualizations, that kind of stuff.
Are there any more questions?